What are the other pieces of evidence that you can name for the hypothesis, I guess, that we're inside some system of those Birkeland currents?
Well, if you start at the scale of the local chimney, there's a whole bunch of features on that scale that become apparent. Like you have actual flow of stars along the center, a stream of stars coming down the central axis. You have a ring of stars rotating around the pinch point. You have the dense wall of cold gas and dust out at the edge of the local chimney. Then they see gas blowing out. I mean, in the mainstream model, what happens is that maybe supernova events in there blast out gas from both ends of these, but they do see a flow of out at the ends of these chimneys. And then we see all the Pleiades cluster itself is somewhere down towards that pinch, all these hot blue stars. And that's another sign of current flow. By the way, that ring of stars around where we'd have the torus, those are hot blue stars, and there's a lot of hot blue stars down in that stream in the center. But the Pleiades cluster itself is a lot of hot blue stars. And then the parallax distance problem to the Pleiades can be explained if there's bending of the difference between the direct and relative parallax can be explained by the bending of light in that direction. And clearly there's not enough gravitational mass to do that. But if plasma bends light, then that's where that would be the way to spot the plasma density.
I wanted to ask, can you explain the difference between these two types of parallaxes that you mentioned?
Well, the direct parallax, basically what you do is you get a bead on an object from Earth or from a satellite orbiting Earth, and then you wait 6 months to go halfway around the orbit, and we use that as a baseline, and then you take another bead on the object, and it's basically trigonometry. It's not quite as simple as that, but you're basically doing trigonometry to estimate the distances. But with relative parallax, what you're doing is you're doing kind of the same thing. You're looking at the star, but what objects are behind that star, distant objects. And then you wait again 6 months and look at the object you're observing and see what background stars are behind it, and then measure the angular distance between those, basically. And you see how the foreground object that you're looking at moves compared to the background stars. But in that case, if light is bent around the object you're looking at, then the separation of those background stars isn't actually right. The star that's directly behind it, there's no light bending then. You're looking at it basically on a straight path. But the objects you're looking at off to the side of that are the ones, their light path is bent, so they're not where they appear to be. And that's going to mess up the angular parallax measurements. And you don't need a lot of light bending. Once you realize how insanely small those parallax angles are, if you're doing a triangle where the Earth's orbit is your baseline, and you're looking at how many light years away those stars are, you can see how crucial a straight line path of light would be if your distances measurements are going to be right. So you don't need a lot of light bending even to really throw that off. And again, you would think the mainstream would be looking for that, but they know that there's not enough gravity in that area to do that. Like with the sun, we only see light bending right near the solar surface. And that was Edward Dowdey's argument why it's not really bending of light the way Einstein would explain, but it's just the bending of light by these plasma double layers. But you see that that's where the issue is. And then the mainstream, of course, massaged that away. They always tell you the problem's solved. If you look at later articles, they'll say the problem was solved, but really what they did is either more parallax by the method that they chose, or else they fit it in with other theories of like stellar brightness and all that. But it really isn't solved, you know, not correctly anyhow.
So as I understand it, kind of the crucial discrepancy between this model and the kind of mainstream gravitational model in terms of observations is that what mainstream calls the local chimney, they consider it being basically a hollow cavity, whereas the Birkeland current model says that, well, it's not hollow, it's filled with plasma that actually carries a strong electric current. It's just that it's invisible because it's in dark mode, right?
Right, and that's where that single structure. That's where all the questions should be for the EU community. Like, you know that can't be hollow. The mainstream is saying it's very sparse, even compared to the relatively sparse atmosphere outside of that. So the question for the EU community is, why don't we see that? Why don't we see the magnetic fields of current flow through there? And Don Scott's model answers that. But then why don't we see it in any other way? And that's where you realize just how much in a minimum energy configuration current filament, all the charge disappears in almost every way that you can look for it. You don't see recombination between electrons and ions. You don't even see interactions between two different ions that might rob an electron from another one. You won't see that if ions are sorted into by Markland convection into the correct shells, and they're all moving together. They're not spiraling around the magnetic field, giving off radiation. Basically, it looks like nothing. It looks like almost a complete vacuum, where we should know the opposite is true. Just by that shape, if you want to explain it as a pinch in a current filament, you know that the plasma density has to be higher there than anywhere else, not just inside that tube, but especially right down in that pinch. So the fact that they're seeing that as a hollow bubble, you have to explain then all the reasons that we don't see the charge there. And like I say, the only hints that we have is that we've got bending of light there that can't be explained otherwise, and those hot blue stars, which in the EU model, that should be a lot of current flow then. But if you have a cluster of, like the Pleiades, fast spinning hot blue stars, that's a sign there's current, so there better be plasma feeding that if the EU model is right.